We're going to talk a little bit today about setting up the fourth axis for a flip to do machining on the top, and then flipping it over, doing machining on the bottom to get the two halves to line up. Thing I hear a lot of is people trying to find the center line of the rotation of the A-axis, and a lot of misconception is if they find the center line of this piece of material, that when they flip it over and do the other half, then the two halves should line up. The biggest misconception about that is when you stick this in your four-jaw chuck to hold it, there's nothing saying that the center line of this piece of material is in the exact center line of the rotation of the axis. What I mean by that is when you clamp it up, the center line of the rotation of the axis could be different. So say, for example, you chucked it up in the center of this piece of material and you happen to get it just right. When it flips, everything is perfect. But if you get it off center, you've still got the rotation of your axis, but what's going to happen is this corner is going to move way over here, like so. And if you watch this dot and this line I have here, if you hold it way off on the side, so you've chucked it off center, when you rotate it, it's still rotated around the center line of where it's being held, but your material that was over here ended up over here. So if you're zeroed in the center line of the rotary table itself, then it doesn't matter how you chuck this up, as long as when you're cutting, material is in the way. So what we've got to do is, in the CAD software, when you draw a part, then this is mainly for the jewelry industry, but your X, Y, Z coordinates is typically center of the part that you're cutting. For example, got a little trapezoid drawn up here, and if you look right here, this is our 0 coordinates, and it's dead center of the part. So when we set the machine up, we have to set the tool tip exactly where this is when we write our software. So this part is 5 millimeters thick, so we've got 2.5 millimeters above Z0, 2.5 millimeters below Z0, so when it cuts the top half, it's only going to cut from here up. When you flip it over and do the bottom half, it's going to cut from the center line down, which when you do a flip, it'll be center line up. And the purpose of this is, well, the reason why we want to find the center line of the rotation or the rotary table is we want all 4 of these corners to line up. If it's off, then you'll have a step here. This whole piece will look like it's shifted over. So when we do that on the machine, there's a couple ways of doing this to get really close.